So in the last video, we saw that it's important now to be able to distinguish between these two different types of integrals. The indefinite integral with no bounds that asks us to find an antiderivative, and a definite integral with bounds that asks us to find an area under a curve. So down below here, we're going to see that there are going to be some properties of indefinite integrals, or properties of antiderivatives, that of course we should be aware of. Now, the first two of these we've actually already talked about back in section 4.10, which is that we can go ahead and use the constant multiple rule in reverse, and we can use our sum and difference rules in reverse to help us try to go ahead and find antiderivatives. Number 3 here isn't so much a rule as it is a non-rule, but it's a very important non-rule to be aware of. If I ever have the antiderivative of a product, right, or I'm trying to find the antiderivative of a product, I cannot say that that is the antiderivative of each piece of the product, because again, that's not undoing any derivative rule. So I cannot do this. Now, if we were to go ahead and take a look at the box on the next page, what we'll be able to see is that we can again start to kind of form a list, and we've mentioned this list before, of different strategies for finding antiderivatives. The number one kind of just top of the list every single time, the thing we're always shooting for, is to recognize derivative rules that we learned earlier in the semester and to just undo them or reverse the direction of them. And if we don't happen to see derivative rules, if we come across something that doesn't look like a derivative rule that we recognize, one of our other tools is to maybe use algebra to rewrite what we have. So that way we can eventually return to seeing derivative rules and just easily undoing them. So as I state down here in the note, this topic of quote-unquote algebra includes things like simplifying expressions, factoring, using trig identities, and a whole bunch of other simplification techniques. Now, this list is by no means complete. We will actually talk about ways that we can actually extend this list later on in this semester, as well as during Calculus 2, you'll continue to add on to this list. So we'll go ahead here and take a look really quickly at something like example 2 to start to at least get an understanding of how I would use this list of strategies. So again, I'll notice here in example 2, I'm asked for an indefinite integral. There are no bounds, so I'm just looking for an antiderivative. So the first thing that I would do is I would start to rack my brain saying, was there any derivative rule ever that had an answer of 1 over the square root of 1 minus x squared? Did that ever exist anywhere? And actually it does, but it's one that maybe you don't quite recall, because it is maybe a little bit more of an obscure derivative rule. But this here is actually a derivative rule for the inverse sine function, or the arc sine function. And so I can easily and very quickly answer this question by just saying, oh, this indefinite integral is equal to the inverse sine of x plus c. So in this sense, I only really had to use strategy number 1, and I didn't need to do anything with strategy number 2. Now, we're going to spend most of the remainder of this section focusing on strategy 2 and how do I actually use algebra to simplify what I have so that way I can get back to using strategy 1. And we'll see here that in examples 3 through 6 that we'll talk about in the videos to come, we'll see a variety of different algebra techniques and practice kind of doing these sorts of simplifications so that you can feel more prepared to tackle questions like these on your own.